So we talked about the basics of atoms in that first video. The very key thing I want you to take out of that is elements are associated with their number of protons. You change the number of protons, you change the element. So as soon as you go from 4 protons to 5 protons, beryllium becomes boron. So that number will not change ever for that element. However, we can change the number of neutrons and we can change the number of electrons. If I change the number of neutrons, I get an isotope. So this is the same element with a different number of neutrons. So a very good example of that would be carbon. You often hear about carbon-14 dating. Well, carbon can come in several different forms. Carbon can have an atomic number of 6, but an atomic mass of 12. Some carbon will have an atomic number of 6. Notice that has not changed, but the atomic number is now 13. Some carbon will still have a total of 6 protons, but now the atomic number is 14. This is why there's a decimal point in the atomic mass. The atomic mass is actually a weighted average of all of the different proportions of these different forms of carbon that can exist. And so if we were to draw these, we would still have our 6 protons. This one would still have 6 neutrons, because remember 12 minus 6 gives us the neutrons. We would still find those in the nucleus. We'd have 2 electrons. So this is the same atom I drew a minute ago when we were doing our example. So C12, because we took that 12.01, we just dropped it, because most of the carbon out there is C12. 6 protons, 6 neutrons, 6 electrons. So if we go to carbon-13 though, the one thing we're going to see change is going to be the number of neutrons. So remember, 6 is still protons. Now 13 minus 6 is going to give us our 7 neutrons. Still have the same 2 electrons in the first shell. Still have the same 4 electrons in the second shell. So notice these two things are identical except for the number of neutrons. C14 is going to go one step further. Now we have 6 protons, we have 8 neutrons, because 14 minus 6 is 8. We have the same 2 electrons in that first shell. We have the same 4 electrons in that outer shell. So carbon can have many different forms. If it changes the number of neutrons, we have different isotopes. So this is the C12 isotope, the C13 isotope, and the C14 isotope. You might also see these displayed as C12, C13, and C14 to indicate that they have different atomic numbers. All right. Actually, I misquoted myself. That should be different atomic masses. We can also change the number of electrons. You just can't mess with the protons, or you're going to change the element. So elements can have different numbers of electrons. If I change the different numbers of electrons, I get an ion. So this is the same element with a different number of electrons. And this will create an imbalance. In the charges. Because remember, if I take away electrons, or if I add electrons, Now I'm going to have more or less. And we give special names to those. If I have a cation, this is a positively charged ion. And if I have an anion, this is a negatively charged ion. And this will happen to a lot of things that are in columns 1, 2, and 7. Now you don't need to remember that, but it's a general trend. So if we were to look at sodium, so sodium in the periodic table is 11, and it has 22.99 as an atomic number. So if we were to draw this, we would have 11 protons. If we ignore the 99, 22 minus 11 would also give us 11 neutrons. Because we have 11 positive charges, we need 11 negative charges. So this would be a balanced sodium. So it's going to have 2 electrons in that first shell because that's the max. 11 minus 2 gives me 9 remaining. So remember, the second shell has a max of 8. So we now have 10 of our electrons distributed. And so that leaves us this one lone electron in that valence shell. Now, atoms like to have complete valence shells. So if we like to also have complete valence shells, which is easier. So I'm going to say atoms like complete valence shells. So to make this third one complete, I would have to add 7 electrons to this. Or if I got rid of this one, I would now have a complete second shell. Atoms like complete second shells. Which would be easier to do? Add 7 electrons or subtract 1? Subtracting 1. So sodium gives up 1 electron. And now, as an ion, it just becomes 11p, 11n. We still have those 2 electrons in that first shell, but now we have a complete second shell. We get rid of that electron in the third shell. But notice, I now have 11 protons. I only have 10 electrons. If I have 11 positives and I subtract 10 negatives, this leaves this ion with an extra positive charge. And so there is the imbalance. Actually, I think that should be an N. There's the imbalance. So when we designate sodium as an ion, we no longer just call it Na, we give it that 1 positive charge. Another example. We can look right next door. We can look at magnesium. So sodium with a plus, it has a positive charge. We could call it a cation. So looking right next door to magnesium, we can see that magnesium in the table has 12 Mg, 24.31. So magnesium would have 12 protons. We ignore the decimal. 24 minus 12 gives us the 12 neutrons. We wrap those up in our nucleus. 12 positive charges need to be balanced with 12 negative charges. So those first 2 electrons are going to go into the first shell. 8 will go into the next shell. We've maxed it out. We can move on to the third shell. And then we would have 2 left over to go into the third shell. So same thing. We want to have full valence shells. So would it be easier to add 6 to this to bring it up to its max, or to get rid of those 2? And that's what happens. Magnesium ejects 2 electrons. So these 2 are going to go away, and it's going to leave us now with our new atom, still having the same number of protons and neutrons, but now it will only have 2 shells. Those other 2 on the outside went away, and now our second shell is full. And now, because it has 12 positives and 10 negatives, this has 2 extra positive charges. So magnesium as an ion would be magnesium 2 plus to let us know that it is an ion. So magnesium balanced is just nothing there. But magnesium with a 2 plus says that we have an ion. And in particular, we have a cation because it is positively charged. So let's look at one more on the other side so you can see what an anion looks like. And so for this, we're going to look at chlorine. So chlorine has 17 as an atomic number, and it has 35.45 as an atomic mass. So a balanced atom of chlorine will have 17 protons given. If we ignore the decimal point, 35 minus 17 gives us 18 neutrons. We wrap those up in our nucleus. We're going to have 17 positive charges, so in a balanced chlorine, we will have 17 negative. So notice there's nothing with it, so that means it is a balanced atom. 2 will still go into the first shell. 8 will still go into the second shell. We're up to 10 of our electrons being distributed. So that leaves us 7 for the third shell. So the third shell, remember, had a max of 8, that octet rule. So now that we're closer to being filled, it is now easier to find an electron floating around in space. And there are tons of electrons floating around in space. So chlorine, to make this third one full, because it just needs to find 1, it's much easier to find 1 than to get rid of 7 like the other guys are doing. So chlorine is going to find an electron and add it to its outer shell. And then that'll be maxed out at 8. It'll be a full valence shell. So my chlorine ion will still have 17 protons, still have 18 neutrons, still wrapped up here. It'll have 2 in the first shell, 8 in the second shell, and if we add 1 to 7, we also get 8 in our valence shell. But now I have 18 negative charges and only 17 positive, which means that this atom has an extra negative charge. So therefore, our chlorine ion will be the symbol with 1 negative sign with it. Now we are having anion. Overall, this ion is negatively charged because it has 18 negatives to 17 positives. So atoms in their balanced state will look like this. But we can change the number of neutrons. And if we do, we get an isotope. Or we can change the number of electrons, and we can get ions. Protons, however, will never change.